This video is about the order of operations, and it's a bit of a review on the topic, but we're going to extend it into some examples, many examples here. Now, in the order of operations topic, it's often taught with this famous acronym, and it can be dangerous. So I'm going to try to clarify this because many students have learned it this way or seen it this way, and it can work with a couple careful qualifications. That is, this acronym PEMDAS, P-E-M-D-A-S, there's all kinds of sayings out there. Some people will say, please excuse my dear Aunt Sally, as a way just to kind of remember those letters. Okay, well, we'll just kind of go with this for now, but with some very careful qualifications. First of all, P stands for parentheses. However, that is not limited to parentheses, so that can be misleading. So I'm going to say it's parentheses or any grouping symbols, which could actually turn into brackets, like squared off brackets, or curly braces, absolute value with these straight vertical bars, or even a square root symbol would count as a grouping symbol. And so let's not restrict this only to be, P for parentheses. This could be any of those symbols. Secondly, E for exponents. So we do things in this order. This is kind of just a conventional order developed in mathematics, and we have to follow it in order to be able to communicate math correctly to people. So P is first, which really means any grouping symbols. Next, E, which means exponents. Okay, next would be M and D, which are multiply and divide. However, those are going to be not in that strict order, but in a group wherein we go left to right. So this is, again, one of the limitations with PEMDAS. If you just kind of strictly follow the order top down, it would appear that M comes before D, and that's true in the acronym, but that's not always true in the actual mathematics. We have to kind of just group these, multiplying and dividing, and go left to right when we have them together in the problem, as we'll see in examples. After that, we have A and S, which would be for add and subtract, but these work in the same way. So they're actually in a group wherein we go left to right. It is not always the case that we add before we subtract, even though A comes before S when we're going strictly down the list. So we just have to be understanding of that and careful when we're applying it. Let's now try some examples where we want to evaluate many different expressions utilizing these rules. I'm going to go ahead and read the problem all the way through at the beginning of each example. And to do so, I'm just going to be careful here. Whenever we see any grouping symbols, as mentioned, that's one of our first steps. Could be parentheses or square brackets. I'll try to articulate that clearly by saying open parenthesis, which would be like only one side, the left side opening up the parenthesis. And then I'll try to say close parenthesis, which would be the right side closing it. Of course, together, the open and close would be called parentheses. Parentheses is plural for parenthesis. And that's what I'll use just to indicate clearly how these are all written out. Same thing with brackets or other grouping symbols. So our first example reads 10 squared, so that's 10 to the power of 2, minus 100 divided by 5 squared times 2 minus 1. So that's just me reading strictly left to right the way the problem is written. Now we want to implement or put to work here our order of operations defined above. And of course, as we've already seen, that would involve any grouping symbols first, but this example has no grouping symbols. So we skip that and go on to exponents, the second item in our list. Now, there are two cases of exponents in this problem. As you may recall from me reading it, there's a 10 squared and there's a 5 squared. Squared is power of 2. And so what I'm going to do, just to be super clear on this, is go really slow and do those steps first, but only those steps. So any exponent I see, I'm going to do that as the first item in our list going down our order of operations. So 10 squared would be 100. I'm just going to rewrite that as 100. And then I'm going to copy everything else down. It can be tempting to do too much at once, and that's usually where mistakes happen with order of operations. So I have 10 squared turning into 100, then I'm just copying down the minus 100 that followed it, and then the division sign. But when I get to the next exponent, I'm going to evaluate that as well. So 5 squared would be 25. And then I'm going to again copy everything else down. So times 2 and then minus 1. Now, you may be tempted to do more than that. I'm just suggesting we be careful and do one thing at a time, because often going too fast is where the mistakes happen. And doing it this way will require you to write out more stuff, use a little more paper, but ultimately it's worth it if it saves you all kinds of points in getting a correct answer. Alright, so we've evaluated the exponents first as the first item in our list. Let's now go through and see what operations remain. If you just look down what we have, there's a subtraction, division, multiplication, and then subtraction. That's just me reading left to right the operations that are there. Well, out of all of those, if you go back up to our list, you'll notice that we have actually 3 different operations: subtraction, division, and multiplication. Well, in our list, multiplication and division would be next, but notice those are grouped where we're going to go left to right. So in this case, we see a division symbol before we see the multiplication symbol. So going left to right, we would actually do the division first out of that pair. We're going to completely ignore the subtraction at this point, because remember, that's pretty much last in our list from what we have here. So given that we know we should do the division next in our problem, I'm going to underline the 2 numbers that are surrounded, or that are surrounding the division. That is the 100 that's to the left of it and the 25 that's to the right of it. Now let's go ahead and recopy the first number, 100, which we haven't even touched yet, and then the minus sign which follows it. But then the 2 numbers that are connected with this division symbol, that's the operation we're doing next. That's just 100 divided by 25, which happens to be 4. So I'm going to replace that pair and that operation with just the number 4, the result of it. Then I'm going to keep copying everything else we have. So after the 25, we still had this times indicated by the dot, so multiply here, so times 2, and then a minus 1. So here we've now gone through and done one step, only one step, but we're being very careful to go in the right order. If we then look at what we have left, we'll again do the same thing, evaluate what operations we have. We have a subtraction, a multiplication, and then a subtraction. Well, out of all of that, multiplication would be next according to our list above. So I'm going to underline the multiplication here, the 4 times 2, and then copy everything down. So 100 minus, and then do the 4 times 2, which is 8, and then continue to copy the minus 1. So now we have, it's getting boiled down or reduced down as we go. That's the whole point. But all we have left is subtraction. Notice there are 2 cases of subtraction here. Well, in subtraction or addition, we simply go left to right. So we're going to have to pick the left pair first. It's not an option. You can't decide, oh, I would really prefer to do the 8 minus 1 at the end first. Sorry, it doesn't follow the order of left to right. So leftmost pair, 100 minus 8, would be 92, and then I'll copy the minus 1 that's after it, and then of course 92 minus 1 would be just 91 as our final answer. Let's move on to our second example. This one has an opening bracket and then 11 minus 4, opening parenthesis, 2 minus 3 to the power of 3 here, close parenthesis, close bracket, divided by 37. So obviously we have some grouping symbols in this problem. We have to be very mindful of that. But notice that we have actually what you could say is nested grouping symbols. We have a set of parentheses that are inside a set of brackets. So what do we do first, right? If grouping symbols or parentheses are the first order, how do we know what to do? Well, when you have nested grouping symbols, you always dive in as deeply as possible to the innermost set. So inside the brackets, we have the parentheses. That's where we're going to start. So I'm going to copy down the opening bracket and then the 11 minus 4, and then I have this open parenthesis, and now I'm working just inside the parentheses to do whatever would come first inside there. It's almost like it's a separate inner problem? Well, we have inside those parentheses 2 minus 3 to the third power. Okay, well, the exponent would have to come first in that sub-problem inside here, which means I'm going to write this as 2 minus, and then 3 to the third power is 27. That's 3 times 3 times 3. All right, so we have 2 minus 3 cubed, which is really 2 minus 27. So that's me doing a step in this problem, but it's only the step that's inside the parentheses, which are inside the brackets. Then we're going to continue copying the closed bracket, and then after that we still have this divided by and then 37. All right, that's just one step. Now let's of course continue by rewriting this all again. We have the open bracket and then the 11 minus 4, and then we're going to go inside these parentheses, which now contain the 2 minus 27, and we're going to evaluate them, because remember, we're still working from the inside out with grouping symbols, or parentheses in this case. So 2 minus 27 happens to be negative 25. We'll replace that now as what's inside the parentheses, close off the brackets, and then finish with divided by 37. Okay, let's keep going one step at a time here. So I'll copy this down again, where we have open bracket, 11 minus, now inside these brackets, we've already written the opening bracket for this. We see a couple different things. There's a subtraction going on between the 11 and the 4, and then there's multiplication going on between the 4 and the negative 25. So there's a couple ways to see that, and what I'm going to suggest is that we kind of underline the multiplying going on between the 4 and the negative 25, but I think it's safer to see that as a negative 4 times a negative 25. So there's always this confusion out there about whether the negative sign in front of the 4 goes with the 4 or is just a minus sign connecting the numbers. It's kind of both, and so you could treat it both ways. If I consider the negative sign in front of the 4 making it a negative 4, then really this is a negative 4 times a negative 25, which is actually a positive 100. So one way to do this problem would be to say we have really 11 plus 100 inside these square brackets. The negative 4 times negative 25 becoming a positive 100. Now, if you saw the negative in front of the 4 separately, then you might write this problem as 11 minus negative 25, but then you would turn that into a 11 plus 100 eventually anyway. So there's really a couple ways to write it. I'm just going to pick this way, and then of course after the closed bracket we still have divided by 37. Alright, so we'll go ahead and now continue again. Inside the brackets we have 11 plus 100, which would be 111, and then divided by 37. And of course that's something you could crunch out, and it turns out it's a nice 3 for the result. Let's try another example. For number 3, our third example, we start with a fraction, and there's several things going on in the numerator and denominator of this fraction. So let me just say from the start here, when you're working on order of operations involving a fraction, you can really treat the numerator and the denominator almost as if they are two different problems, where you do one thing on the top and one thing in the bottom for any given step until you run out of stuff to do. So this problem reads, as it begins here, with a numerator of negative 5, open parenthesis, 7 minus 2, close parenthesis, minus 3, open parenthesis, 4 minus 7, close parenthesis. That's the numerator. The denominator is negative 13 minus, open parenthesis, negative 5, close parenthesis. Alright, if we look at the numerator and pick one thing to do in it as our first step, you'll notice it has parentheses, two sets of them, which would be grouping symbols, and so we should start there according to our order, which means on top I'm going to recopy the negative 5 just as is, but then after it, in the parentheses was 7 minus 2, so I'm just going to turn that into 5, which is now in the parentheses all by itself. Continuing on, we'll say minus 3 times, and then we had 4 minus 7 in the second set of parentheses. Well, 4 minus 7 is negative 3, And so that's how we can reduce that set of parentheses. So that's really doing one step all the way across the numerator of this problem, and we'll leave it at that for now. Now we're going to go down to the denominator and do a similar kind of thing where we just do one step. Well, the denominator was this negative 13 minus negative 5, and so the double negative there is going to turn into a positive. So I'll recopy this as negative 13 plus 5. By the way, a double negative turning into a positive like that is actually an operation that would be considered multiplication. So if you have to put it in an order somewhere in the order of operations, that's a multiplication step, but there wasn't anything else that would have come before that in this denominator. That's why we did that. Alright, so now we have a new denominator of negative 13 plus 5, which means we've done one step in the numerator and one in the denominator. Now we'll just kind of restart and do another step in each part. In the numerator we have really multiplication and subtraction going on. We should do the multiplication before the subtraction according to our order. Negative 5 times 5 in this first part of the numerator would be a negative 25. And then you could consider this second part kind of like one big step. It's negative 3 times negative 3, which would be a plus 9. You could also consider that, minus 3 times negative 3, which would be a minus negative 9. Ultimately, it will turn into a plus 9 eventually, though, so you can just write it as plus 9 now. And then that takes care of the numerator. We've done all we can up there for now. If we go down to the denominator, you'll notice there's a negative 13 plus 5. Well, that's only really one thing to do. We can put those together as negative 8. Alright, so the denominator is done. It's down to a single number, but there's a little more to do in the numerator, which we have as negative 25 plus 9. If we add those up using our rules for addition and subtraction of signed numbers, we should get a negative 16 up there. And then down below we have a negative 8. Of course, now negative 16 over negative 8 is positive 2. And that's where we can finish. So as you can see, doing a fraction problem involves maybe a little more thinking and separating of steps, but it's all the same thing, all the same order of operations. Let's move on to a fourth example. This one begins as 4, open parenthesis, negative 15, close parenthesis, plus absolute value, opening, 3, open parenthesis, negative 10, close parenthesis, close absolute value. Alright, so we have several grouping symbols going on, and really we could be picky and start with the absolute value since those are considered the grouping symbols. By the way, parentheses are grouping symbols, but in this case, parentheses are used as multiplication. There's nothing to do inside of the two sets of parentheses here. They're just holding numbers. So that's one way parentheses can be used, which doesn't quite count as grouping symbols. They're just multiplying symbols. But here we'll start just to be really picky with the grouping symbols of absolute value. We mentioned in the list above, those count as that. So I'm just going to copy down the 4, open parenthesis, negative 15, close parenthesis in the very front here, and then plus, and then I'm going to copy down the open absolute value. Inside them we had 3 times negative 10, really that's a negative 30, and then close absolute value. So we're just doing what's inside the grouping symbols here first, strictly following our order above. Now if we kind of restart, what we have left is this 4 times negative 15 in front. That's really just a negative 60. That's just multiplication here. And then plus. And then this absolute value, being used here, we have absolute value of negative 30. That's really just 30. And then we can go ahead with our addition of signed numbers here. We have negative 60 plus 30. Ultimately, that would be negative 30. And that's where we could stop with that example. Let's try some more examples. Our fifth one is also a fraction as it begins. The numerator is 3/5 minus 7/10. The denominator is 1/2. So we have fractions in this fraction. Now if we go through and just work on the numerator alone, you'll notice it needs a common denominator. So we could say the LCD for those two fractions, of course having original denominators of 5 and 10, would be 10. So let me just write in our LCD here as 10, which means for the first fraction, the 3/5, I'm going to have to multiply top and bottom by 2 in order to get this new common denominator in play. And so really the new numerator will be 6, and then we'll have 6 over 10 minus 7 over 10, which now means we have a common denominator. That's the numerator. Of course, I'm going to copy down the 1/2 we still have alone in this major denominator down here. But then we have this 6/10 minus 7/10. I could compute that as negative 1/10. And then below it, I'll copy down the 1/2. So we did the subtraction in the numerator there as our next item. But now notice we have a fraction over a fraction, which is really a division of fractions. So one way to think of this, just to be safe about it, would be to write the numerator as negative 1/10, and then really we're dividing by 1/2. When you say negative 1/10 over 1/2, that's like negative 1/10 divided by divided by a positive 1/2. But then, as we've seen with reciprocals, division is just multiplying by a reciprocal. So we're going to change flip this one as negative 1/10 times, so keep the first, change to multiplication, and then flip the second, so times 2 over 1. Okay, and then we can reduce this even as we go here with the 10 and the 2. You could divide those each by 2, which would give us a 5. And so 10 divided by 2 is 5. 2 divided by 2 is 1, which means we could put this all together by multiplying across the top. Now it's a negative times a positive, resulting in a negative. On top we just have 1 times 1, which is 1. And down below we have 5 times 1, which is 5. So negative 1/5 should be our ultimate answer for this one, including all the order of operations we've done with it. If we go back up to the example 6 we have next to it and start over with this new one, let me begin by reading the problem. We have open bracket, negative 4/7 minus, open parenthesis, negative 2/5, close parenthesis, close bracket. Then we have another open bracket just right next to it, so negative 3/8 plus open parenthesis, negative 1/9, close parenthesis, close bracket. Okay, so we're going to start by understanding that there are two major grouping symbols going on here with these brackets. So we should kind of be thinking of whatever's inside those brackets kind of like as its own problem that we should start with, since we're starting with grouping symbols in our order. So in the first bracket, we have negative 4/7 minus negative 2/5. Well, we can understand a double negative going on there, so I'm just going to copy down the open bracket and then rewrite this as negative 4/7 plus 2/5. The double negative turning into a positive there for that one. I'll leave that alone for a second. We have more to do there. But let's move on now to the second bracket, opening bracket that's after it. And here we can do something similar, which is I'm going to copy down the negative 3/8. And then when we see a plus negative, as this plus negative 1/9 here after it, that's not a double negative. In fact, those are different signs. Well, when you have different signs, you could just translate it to be a minus sign. So plus negative is the same thing as minus. Or, minus positive, again, same thing as a minus. When the signs are different, you can just write it as a singular minus sign. And then we have a 1/9 after it, and then we'll go ahead and close the bracket. Alright, now that we've done one little step of just kind of simplifying some of the positive and negative signs here, we can go ahead with the fraction steps. You'll notice inside the first set of brackets, we're going to need an LCD. For 7 and 5, it would end up as 35. And so for that LCD, to convert the numbers, we'd have to multiply 7 times 5, therefore 4 times 5 above it. We'd have to multiply 5 times 7, and therefore 2 times 7 above it. And so if we carefully recopy what we have here, inside this first set of brackets, we really have a negative, and then 4 times 5 would be a 20. So negative 20 over 35 plus the second fraction would be 2 times 7 up top, so 14 over 5 times 7 or 35 below that, and that is inside this first set of brackets. So negative 20 over 35 plus 14 over 35. Okay, we'll go ahead and handle that in the second step after this, but for now let's move on to the next set of brackets where we have something similar here. We have two different denominators. We'll need an LCD. Now for the denominators of 8 and 9 that we have in this one, we could say their LCD would be 72. So to get that and convert these, I'm going to have to multiply the 8 by 9, and therefore above it the 3 times 9 as well. Moving on to the 1/9, I would have to multiply the 9 by 8, and therefore above it the 1 times 8. This will allow us to take a step in the fractions here. So the first fraction in this second bracket is going to be negative, and then in the numerator 3 times 9 would be 27. The denominator, of course, is 72, as we've already discussed. Then we'll say minus. Second fraction would be on top, 1 times 8, or 8, and down below also 72. Alright, so now we're ready to do the arithmetic with these fractions. We'll go ahead and rewrite the entire problem. The first set of brackets had a common denominator of 35, so we're just going to copy now one denominator of 35 since we've already done all the LCD work. Of course, we do the actual addition or subtraction here as negative 20 plus 14. That's across the top of these fractions in this previous step. That will result in negative 6. So all we have inside the first set of brackets here is really a negative 6 over 35. Close the brackets. Now in the second set, similarly, we can go ahead across the tops of these. We have a common denominator of 72. On the top we have negative 27 minus 8. That would end up as a negative 35. And so close that bracket. We're good there. Now notice what's left is that we've boiled down each bracket into a single fraction. But between the brackets is really nothing. These brackets are just kind of smashed next to each other. Well, that would result in what we could consider a multiplication operation, which is why that means we're going to multiply these fractions together to finish this problem off. Now to multiply fractions, of course, we may need to reduce, and as we've seen, you can reduce kind of before you multiply. So you'll notice we have some 35s on top and bottom, and you can reduce across the multiplication operation, which is why it's important to note that that's what we're doing. If I divide those 35s each by 35, I would have a 1 and a 1. Now, the 6 and the 72 could also be reduced. I could divide those each by 6. 6 divided by 6 is 1, and 72 divided by 6 is 12. And so we're just kind of reducing as we go here. It's a slightly simpler way to reduce, as long as you can stay organized, and using different colors can help with that. But if we now look at what we have, across the top we have a negative 1 times a negative 1, which is actually a positive 1. And then across the bottom we have a positive 1 times a positive 12, which is a positive 12. So it turns out positive 1/12 is our final result for that one. Next we'll work on evaluating, and doing so by plugging in numbers for letters like we've done in the past, and then also implementing order of operations as we do that. So our first example for this segment reads negative x squared minus 14x, and we're plugging in x as negative 1. Well, as we've already seen, when you're substituting a number for a variable, we're going to do so carefully by first rewriting a blank set of parentheses instead of the variable. So instead of negative x squared, I'm going to write negative blank squared, and in the blank I'm going to put our negative 1. Moving on, I'll have minus 14 blank instead of 14x, and again in the blank I'll put a minus 1 because that's what we're plugging in for x. Now this is where you're going to see the careful power of these parentheses. When we first did this, it may have seemed like overkill, but now that you're seeing exponents involved and multiple negative signs floating around, doing this extra step where you replace a variable with blank parentheses first and then plug the number in the parentheses really saves, it really starts to save you points and mistakes here. Now, what we have left, if I could read it across, is negative, open parenthesis, negative 1, close parenthesis, squared, minus 14, open parenthesis, negative 1, close parenthesis. If we now apply our order of operations here, we have to be super careful because at the first part, you see this negative, negative 1. It's very tempting to look at that and go, hey, double negative, that's really positive. Well, okay, yes, but remember we said earlier that doing a double negative to a positive is actually a multiplication step, but that would not come before exponents, which we also have here. So this is a really common mistake. We got to be careful of this. We're going to leave that initial negative as it is, just copied straight down. I'm going to do the negative in parentheses, the negative 1 in parentheses squared. That turns into just a positive 1. That's what we're going to have to do first. It's common to see this accidentally turn into just a positive 1, thinking it's a double negative when really you have to do the exponent first. Just be careful with that. Moving on, we now have minus 14 times negative 1. Well, negative times a negative is really a positive. So I'll just make this plus 14, which means we really now have negative 1 plus 14. Ultimately, of course, that would be positive 13 as our final result. Let's move on to a second example in this piece here where we're plugging in a value for the variable. The expression is a fraction wherein the numerator is 3y minus 2y squared. The denominator is y, open parenthesis, y minus 2, close parenthesis. And we're plugging in y as 5 for this. So as we've been doing, we want to use parentheses here to be super careful. In the numerator of our expression, I had a 3y. I'm going to write that as 3 blank. And in the blank, I'm going to put a 5. That's what we're plugging in for y. Then continuing on, we have minus 2y squared. I'm going to make that a 2 blank squared. And then in the blank, plug in a 5. In the denominator, we had a y. I'm going to put that as just a blank parentheses and put a 5 in its place. Then it was open parenthesis, y minus 2. Well, that would be blank with a 5 in it, minus 2, close parentheses. Now we can go ahead and be really careful with our order of operations here. Across the top, we really have multiplication, subtraction, multiplication, and exponents. So be careful here. We have to do the exponents first, meaning I'm going to copy down the 3 times 5 in parentheses there, copy down the minus sign, copy down the 2, and then turn this 5 squared into a 25. We have to be careful on the order here. It's going to make a different answer if you use a different order. So that's our first step in the numerator. Down below in the denominator, I'm going to copy down this 5 in front, and then we have grouping symbols here, the 5 minus 2. That will do next to make it really just a 3, so that the entire denominator now is just a 5 times 3. Now I'm going to do another step in the numerator, which would be really just the multiplication. We have 2 instances of it. We have 3 times 5, which is 15. Copy the minus sign down. Then we have 2 times 25, which would be 50. And so really it's just 15 minus 50 in our numerator. Below that we have 5 times 3, that's just 15. And so now we can simplify the numerator, which was 15 minus 50, that's really a negative 35. Over, we had a 15 down below. Now this can be reduced. It's not a single integer answer, but you could reduce it by dividing both top and bottom each by 5. That's a common factor. And so the result of this fraction, of course, negative over positive will be negative. 35 divided by 5 would end up as 7. And down below, 15 divided by 5 would end up as 3. So negative 7/3 is our final answer there. For our last pair of examples here, there's a slight modification in the instructions that I'm going to write in here. So instead of just substituting a number in, for these we have variables, we have numbers, we need to use order of operations, but we're not actually plugging anything in for the variables. So these would be instructions that might say something like just simplify. So we're just looking for a simplified answer for these. The first problem reads 4 open bracket 6 open parentheses or parenthesis x minus 3 close parenthesis plus 1 close bracket. Now, given what we've already understood with some basic algebra principles here, there is something to do in this, which is to distribute this 6 inside the brackets we have that gets distributed inside the parentheses. So again, we're doing order of operations where we do the nested grouping symbols first, so we dive way inside here. If we distribute that 6 but do nothing else, we'll end up with 4, open bracket, 6x minus 18 plus 1, close bracket. Then we'll look inside the brackets and see two like terms to combine here. I could recopy this as 4, open bracket, 6x, and then this minus 18 plus 1, those are like terms, it's just numeric terms. We could combine them and get a negative 17, close bracket. And then lastly, we'll distribute this 4 inside the brackets, finally here, to end up with 4 times 6x would be 24x, and then 4 times negative 17 would be a negative 68. So 24x minus 68 is our most simplified answer. There are no more like terms to combine, that's how we know we're done. If we move on to the fourth example here in this segment, we could do something similar. This one reads 4, open parenthesis, 6x squared minus 3, close parenthesis, minus, open bracket, 2, open parenthesis, 5x squared minus 1, close parenthesis, plus 1, close bracket. Now, we'll want to do some distributing right away. We want to dive down as much as we can with it as well. You'll notice two chances to distribute. The 4 could be distributed to the parentheses that follow it, and inside the brackets, the 2 could be distributed into the parentheses that follow it. Now you may say, well, we should start inside the brackets first, right, because of nested grouping symbols? Yes. However, the two distributing steps that we've just kind of pointed out here don't affect each other, so you could actually do them as the same order or the same step. So if we start on the outside, we have 4 distributing in, that would give us 24x squared minus 12. Keep the minus sign that's outside these brackets, and then inside the brackets, distribute the 2 to get 10x squared minus 2, and then the plus 1. That's just doing the distributing inside the brackets there. Now we'll have to distribute again. There's a negative sign out in front of the brackets that we were just working on. That negative sign needs to be distributed inside. But actually, before we do that, why don't we combine the like terms that we see inside the brackets? Really, there are a couple different maybe steps you could take here, but I'm going to do that first. So I'm going to copy down the 24x squared minus 12 minus, open bracket, and then we'll have 10x squared, and then really it's a minus 1 if we combine those numeric like terms there. Okay, now we'll go ahead and distribute the subtraction or the negative sign that was in front of the brackets to both terms inside it, so that we end up with 24x squared minus 12 minus 10x squared plus 1. Now we've distributed, we have no more grouping symbols left. All we do is look for like terms to combine, and indeed we have some. There are some x squareds we could combine, and then there are some numeric terms we could combine. Those are two different pairs of like terms. If we work on the x squareds first, there's a 24x squared and a minus 10x squared. That would give us 14x squared when combined, and then the negative 12 plus 1 would give us a minus 11. So 14x squared minus 11 is our simplified answer for this one.